Hi, my name is Alexandra Sarmento and I'm from environmental engineering student. In this time I will do my presentation about green chemistry and I'm more focusing on green chemistry in the industrial. Green chemistry emerged in response to growing concerns about environmental and health impacts of traditional chemical processes and products. It encompasses a wide range of practices from using renewable feedstock and energy sources to designing biodegradable materials and reducing the generation of hazardous byproducts. The field promotes innovation and collaboration among chemists, engineers, and policymakers to create a more sustainable and environmentally friendly chemical industry. It's not just about minimizing harm, but also about creating opportunities for economic growth and societal well-being through responsible chemical innovation. So in this statement, it says that green chemistry is a field that has emerged in response to the increasing concerns about the negative impact of traditional chemical processes and products on the environment and human health. It focuses on developing sustainable practices within the chemical industry by incorporating principles that aim to reduce or eliminate the use and generation of hazardous substances. So there are three important roles of green chemistry: environmental protection, human health improvement, and sustainable development. In environmental protection, green chemistry helps minimize environmental impact of chemical processes by reducing pollution, conserving resources, and promoting the use of renewable feedstock. This contributes to safeguarding ecosystem biodiversity and natural resources. In human health improvement, by developing safer alternatives to toxic chemical, reducing exposures to hazardous substances, green chemistry plays a vital role in protecting human health. It helps mitigate health risks associated with chemical products and processes, benefiting both workers and consumers. In sustainable development, green chemistry supports the transition towards a more sustainable and resilient economy. By integrating environmental consideration into chemical design and production, it contributes to achieving sustainable development goals such as reducing greenhouse gas emission, promoting resource efficiency, and fostering social equity. In environmental protection, this is how the green chemistry lessens environmental harm from chemical processes by cutting pollution, conserving resources, and favoring renewable materials. And this also approach helps protect ecosystem biodiversity and natural resources. In human health improvement, emphasizes how the green chemistry enhances human health by creating safer alternatives to harmful chemicals, thus reducing exposure to toxins. This also approach lowers health risk linked to chemical products and processes, benefiting workers and consumers. In sustainable development, this outlines how the green chemistry fostered a shift towards a sustainable and resilient economy by incorporating environmental concerns into chemical design and production. It also helps accomplish sustainable development objectives like cutting greenhouse gas emissions, enhancing resource efficiency, and promoting social fairness. So these are the three important roles in green chemistry. Green chemistry in industrial. Green chemistry is expanding its wings from academic laboratories to industrial units. Sustainable practices include replacement of volatile organic solvents, which constitute the bulk of reaction material, developing recyclable catalysts, developing energy-efficient synthesis, and encouraging the use of renewable starting material. By following the principles of green chemistry, turnover many companies have increased immensely, leading to both environmental as well as economic benefits. This review explores various examples wherein green chemistry has enhanced the sustainability factor of industrial processes immensely and suggests a measure which should be taken to promote as well as popularize the green practices in synthesis. So, in this text, it says how the green chemistry, also known as sustainable chemistry, is a concept that focuses on designing chemical products and processes that reduce or eliminate the use and generation of hazardous substances. It also aims to promote environmental sustainability by minimizing the negative impact of chemical processes on human health and also the environment. In recent years, green chemistry principles have been increasingly adopted in industrial units to improve efficiency, reduce waste, and enhance sustainability. Replacement of volatile organic solvents. One of these key practices in green chemistry is a replacement of volatile organic solvents with safer alternatives. These solvents are also often used in large quantities in industrial reaction but can pose significant health and environmental risk. By substituting them with greener alternatives such as water or ionic liquids, companies can reduce their environmental footprint and improve worker safety. So these are the examples of how green chemistry enhances sustainability in industrial processes. They are replacing hazardous solvents, developing recyclable catalysts, energy efficient synthesis, utilizing renewable starting materials, waste minimization and valorization, and life cycle assessment. In replacing hazardous solvents, industries are adopting greener alternatives to traditional volatile organic solvents, such as using water or supercritical carbon dioxide as solvents. These reduce toxicity and environmental pollution while also improving worker safety. In developing recyclable catalysts, green chemistry involves designing catalysts that can be recycled and reused multiple times. This reduces the consumption of catalysts and minimizes waste generation. So developing of recyclable catalysts is one of the important aspects of green chemistry in industrial settings because catalysts play a crucial role in many chemical reactions but are often wasted after use, leading to increased cost and waste generation. By designing catalysts that can be easily recovered and reused multiple times, companies can minimize waste generation and improve process efficiency. In energy efficient synthesis, a green chemistry emphasizes the importance of energy efficiency in chemical process by optimizing reaction conditions, using renewable energy sources, and implementing innovative technologies such as microwave or flow chemistry. Companies can reduce energy consumption and greenhouse gas emission associated with chemical production. Key application of green chemistry in the industrial. The traditional industrial processes often rely on volatile organic solvents, which can be harmful to human health and the environment. These solvents are often used for purposes such as cleaning, extraction, and synthesis in industries ranging from pharmaceuticals to electronics manufacturing. However, their use poses risks such as air pollution, toxicity, and potential for environmental contamination. Green chemistry addresses these challenges by promoting the development and adoption of safer and more sustainable solvents. Key aspects of this application include designing safer solvents, reducing waste and emissions, improving process efficiency, and promoting circular economy. In designing safer solvents, green chemistry focuses on the design of solvents that are less hazardous to human health and the environment. This involves selecting solvents with low toxicity, low volatility, and minimal environmental impact. For example, water is often used as a green solvent due to its abundance, non-toxicity, and recyclability. So, in this part, water is often used as an example of a green solvent because it meets many of the criteria for safer solvents in green chemistry. And it is abundant, non-toxic, and recyclable, and it has low volatility and poses minimal environmental impact compared to many other solvents. Therefore, it serves a prime example of how designing safer solvents can be achieved. In reducing and waste emission, green solvents are designed to minimize waste generation and emissions throughout their life cycle. This includes considerations such as biodegradability, recyclability, and the use of renewable feedstock by minimizing waste and emission. Green solvents contribute to environmental sustainability and regulatory compliance. So, in this part, reducing waste and emission involves minimizing the amount of waste generated and the release of harmful substances into the environment. This can be achieved through practices such as recycling, waste reduction strategies, and implementing cleaner production techniques. By doing so, we can mitigate environmental pollution and promote sustainability. In improving process efficiency, green solvents can also improve process efficiency by enhancing reaction rates, selectivity, and yield. For example, ionic liquids are a class of green solvents that offer unique properties such as tunable polarity and high stability, making them suitable for a wide range of industrial applications. In improving process efficiency involves optimizing operations to achieve higher productivity with fewer resources. And this can be also achieved through reducing energy consumption and implementing advanced technologies. By improving efficiency, business can enhance productivity and also reduce costs and minimize environmental impact. And in ionic liquids are often cited as an example of improving process efficiency. It's because they possess several beneficial properties that can enhance industrial processes. Like, one is low volatility. Like, ionic liquids have negligible vapor pressure at ambient temperatures. It reduces the risk of emission and making them safer to handle compared to traditional solvents. Last but not the least, the key application of green chemistry in the industrial is promoting circular economy. Green chemistry principles encourage the adoption of solvent recovery and recycling strategies to promote a circular economy. Solvent recycling technologies such as distillation and membrane separation enable the recovery of valuable solvents from the waste streams, reducing the need of virgin materials and minimizing environmental impact. So, in promoting circular economy in green chemistry, it involves designing products and processes to minimize waste and maximize resource efficiency. This includes using renewable resources, recycling materials, and designing products for reuse or remanufacturing. By embracing circular economy principles, green chemistry aims to reduce environmental impact and create a more sustainable and resilient economy. So overall, the development and adoption of environmentally friendly solvents exemplify the transformative potential of green chemistry in the industrial sector. By replacing hazardous solvents with safer alternatives, green chemistry contributes to safer workplace, reduced environmental impact, and sustainable industrial practices. So the conclusion in my presentation of green chemistry in the industrial sector is that it has shown significant progress and potential for creating a more sustainable future by implementing green chemistry principles. Industries have been able to reduce the use of hazardous substances, minimize waste generation, and adopt more environmentally friendly practices. This shift towards green methodologies has not only led to environmental benefits by reducing pollution and waste, but has also resulted in economic advantages for companies. The adoption of green chemistry practices has enabled companies to develop less hazardous processes, shift towards bio-based synthesis, and replace oil-based feedstock with renewable starting materials.